Hi everyone. Tonight we're going to talk about how to find equivalent expressions. What we mean by equivalent expressions are two expressions that have the same overall value, regardless of what the value of the variable is. So for instance, if we look at our first example here, 3x plus 4 and 4 plus 3x. It doesn't matter what x is, these two expressions will always be the same no matter what, because of the associative property. I'm going to fix my pen here. Okay. So we're going to label this as being a result of the associative property. And remember, that just says that when we change the order of parts of an expression, it doesn't affect our overall answer. And that applies to problems that involve addition and multiplication. So this, again, will not work if you have division or subtraction. Another example is this one where we've got 2 times the sum of x squared and 3 and 2x plus 6. You should hopefully recognize this as the distributive property, as we've been working on that for the last couple of days. And that, remember, says that this 2 can be distributed to everything inside the parentheses to get a rewritten expression that will give you the same answer, okay? And one way I want you guys to think about that is, remember, if we are drawing, for instance, what x squared plus 3 would look like for our algebra tiles. We could draw an x squared, right? Plus 3 little constant tiles, right? So we've got this whole thing needs to get multiplied by 2, okay? Now, if I were to multiply it by 2, then that's the same thing as if I were to have x squared plus my 3 little constants twice. And remember, I can rearrange this and rewrite it to be like this. So I've got my 2x squareds, in other words, giving me 2x squared. And then I've got my now 6 constants. Okay. And there's my rewritten form of my expression from a model's perspective, okay? Remember, anytime that you're stuck on trying to figure out how you can rewrite an equivalent expression, always go back to the algebra tiles or drawing the models of them. It can really, really help you to see ways that we can rearrange our terms to help us get an equivalent expression. And then last but not least, we have 2x plus 5 plus x plus 3 and 3x plus 8, okay? So for instance, with these two examples, if we've got 2x plus 5 constant plus x plus 3, then this can be rearranged and written so that we've got 3 x's together, and we've got now 8 constants. Okay, so again, this can be rewritten when you've got 3 x values together. Remember, that's the same as saying 3 times whatever x is. So that can just be 3x plus however many tiles we've got for constants, which is 8. So this original expression, which was 2x plus 5 plus x plus 3, now becomes 3x plus 8. Okay, next we're going to talk about the distributive property alone, and that's, remember, just how we distribute the number outside parentheses to the numbers that are inside the parentheses, okay? So we can rewrite it as the sum or the difference of the product of each of these numbers. So what we mean by that is we're looking for the sum of, or the difference of, since this is subtraction, we're going to do difference. So this will then be some product minus another product. And the first product needs to be 5 times x squared. Our second product has to be 5 times 3. So that simplifies then to 5x squared minus 15. For our next example, 6 gets distributed to the 2x and to the 4, which makes this 6 times 2x plus 6 times 4, which then becomes, well, that's a mistake. This should be 12x plus 24. And next, we're going to work backwards here. We're going to subtract out, we're going to factor out the common factor between 4 and 14. Now, the only number that can go into 4 and also go into 14 is the number 2. So let's rewrite this as the difference of two products. So 4x can be written as 2 times 2x minus 14 can be rewritten as 2 times 7. Now, similar to the format that you guys will remember from before, we now have to rewrite this to fill in our blank spaces. So the number that we have in common goes on the outside, and what's left over goes on the inside. So that'll be 2x minus 7. Okay, so like terms are terms of an expression that have the same variable raised to the same power. In our first example, we have 3 plus x plus 4x plus 5. Now, when we go to simplify this expression, we can only combine terms that have the same, or that have like terms. So they have the same variable raised to the same power. So let's start by looking at this example from what our algebra tiles might look like and see if that helps us to rearrange them in a way that will help us to combine our like terms. So we'll start with our 3 constants. We have an x, then we have 4 more x's, and then we have 5. Okay, now if we go to combine this and add it all together, notice how many x's we have. All in all, we have 5 x's. Okay? Now, if we add up our constants, we've got 3 here, and we've got 5 here, which in total gives us 8. So what we've done is we've just combined all of our like terms. We recognized how many x's we had in total was 5 of them, and how many constants we had in total was 8. All right, the next problem is going to be a little bit trickier because it's a lot longer, and now we're throwing in some exponents as well. So the first thing I want to point out is that notice here x squared, which remember looked like this, and x are not like terms. We cannot combine these two things together because we do not know what x is. So we're going to have to take a little bit different approach. And given that there are so many terms in this example, we're going to try to rearrange the problem a little bit to help us out. Notice how in previous examples, when we drew models, we rearranged the tiles to look a little bit different, but still give us the same answer. So we're going to do the same thing here. So let's start by rewriting this with all of our x squared values first. So that'll be 2x squared plus another x squared. Then we'll write our x values, our x terms, which is 3x and an x. And then our constants, -5 and +8. So when we simplify this, our like terms, here are 2x squared and x squared. Our next set of like terms is 3x and x. And then our last set is our constants. So, to combine these, 2x squared plus x squared makes 3x squareds in total. 3x plus x gives me 4x. And then -5 plus 8 will give me +3. Okay, and our last example is 6x minus 3 minus 2x plus 9. So we'll start again by rearranging this and writing it so that our variables come first. I'm going to do it down here, so it'll be 6x minus 2x minus 3 plus 9. So now I can combine my terms with variable x and my constants together. 6x minus 2x leaves us with 4x's left, and -3 plus 9 gives us +6. And last but not least, we're going to consider some examples where we may need to use the distributive property and combining like terms to find an equivalent expression, or perhaps the most simplified expression. So in this first example, we have 3x squared plus 4x minus 3. We're going to answer problems like this using the order of operations. So we'll start by looking within the parentheses and see if we have any like terms that we can combine. And it looks like in this example we do not. So that means we're ready to move on to using our distributive property to take care of everything inside the parentheses. So that'll leave us with 3x squared plus 12x minus 9. Note that that's 3 times a -3 to give us a -9. And then at the end, we've got that leftover minus x squared. So now I can simplify these a little bit further. And note that I've got 3x squared, and then at the end I take away an x squared, which will give me 2x squared left over. I still have my 12x and my -9. Okay. Our next problem, again, we start with our order of operations. So looking within our parentheses, 4x plus 2 cannot be combined to or simplified any further. So let's go ahead and do our distributive property. We'll leave our 6x out front. 3 gets distributed to the 4 to give us 12x. And note with this negative that was in front of that 3, that needs to go to both parts of, or both terms of this simplified expression. So this is minus 12x, and then it's going to be minus 6 for 3 times 2. All right, and now we've got 6x's with 12 taken away, which is going to put us at negative 12x with our minus 6 remaining. And last but not least, we have 3x plus 2 times the sum of 3 and x squared plus 4x squared. So again, when we rewrite this, we're going to do 3x plus 6 plus 2x squared. Note that those two terms just came from my distribution right there. And then I've got plus my 4x squared at the end here. Now I can, because these are so long, I've got so many terms, I'm going to kind of rearrange them a little bit to help me keep track of them. So this is 2x squared plus 4x squared. Remember, I'm going to start with my variable to the highest power first. So that's why I wrote my x squared values first. Then I've got a 3x and I've got a 6. Now I can combine them. 2x squared and 4x squared give me 6x squared plus 3x plus 6. Now, if I really wanted to get creative, then I could look at this problem and recognize here that all of these have a common factor, okay? And that common factor would be 3. So I could even use the distributive property for this whole expression and rewrite this as 3 times 2 x squared plus 3 times x plus 3 times 2. Now I can use my distributive property and pull out that common 3 and then rewrite this as the sum of 3 different terms. And what's left over in here is 2x squared. Here is my x, and there is my leftover 2. Okay, once you've got your notes down, then you guys are ready to move on to trying some problems on your own on the back. You'll notice at the bottom there is an opportunity for you to earn Grizzly Bucks by answering the question that asks you to find or write the perimeter in at least 2 different ways.